turning the stream on and getting a little work done. So it's bonus day, guys. It's bonus day. 3.5. We're going to let the stream build up just a little bit. And then we're going to jump right in. We're not going to wait too long. I'm going to send a tweet out, let everyone know that I'm live. And if they want to come out and hang out with me, they can. So here we go. 8-bit RPG day. Okay. Just sending out my tweets. That'll do. That will do. Close that out. So I'm just closing some things out now. Make sure we're ready. And get cracking up and running. We're going to get our stuff up and running while we wait people to filter in. Save us a little bit of time. Save a little bit of time. Okay, get Unity up and running as well. I didn't want to load that project. There's nothing in that project. Let's do that again. Let's try that again, guys. That's what we want. You know it, Scaris. You know it, buddy. Welcome to Super Secret Bonus Stream. How's it going, man? How you doing tonight? Let's get this up and running. Just make sure we're in a good state. It's going to be a fun stream, I think. It's all about AI tonight. We are drinking, and we're going to be programming some game artificial intelligence. I can't wait. Oh, new round. Oh, excuse me. Excuse me. Oh, man, our game is coming along so nicely. Got my own views. Yeah, Scaris, I'm too old. Unfortunately, I'm too old to go out and do the New Year's Eve extravaganza thing. I would much rather be indoors somewhere, eat somebody's house, right? Preferably my own. Not having a New Year's Eve party this year, so I have some time to write some software. That actually might sound a little sad, but I'm okay with it. It's okay. It's not sad at all. Not one bit. No, we'll be good. Oh, God, guys. Apparently, I have my own stream audio on. Apologize for that. That was ugly. That was ugly. I'm going to go over to my GitHub. And I'm going to set up the features that we're going to be working on today. Or I might actually already have these. Let me see here. Nope, I do. So we're just going to go and create it. And then we can get going. Give this label, set it to our milestone, assign it to myself, created, 22, okay. Okay. So good evening, everyone. Come join the fun. Have a drink on me if you're out there. Just send me the bill. What's everyone up to tonight? Set up. Keep that open. It's going to be a fun night. If anyone joins and they're an old-time listener from another game we used to work on, some of this might be familiar to you guys. We're going to be working on some AI tonight. We're going to be working on our basic AI system. Going to get that up and running. And we're going to be implementing our AI using behavior trees, and we're going to be doing it in Unity. Now, I know there are some behavior tree assets in the store, in the Unity store, and they're for purchase, and they're probably very, very good. We're not going to be using any of those. We're going to be writing our own, just because I like working on AI stuff. But I'm sure those behavior tree systems are very good. If they're within your budget, consider buying them instead of writing your own. I've written a lot of behavior tree systems, so I know what I'm doing when I jump into this. I've never written it in Unity. We'll see how that goes using coroutines in Unity. Should be fun though. But just so word of the wise. However, once we have our basic behavior tree system up and running, you'll see how I add it into our battle system for our AI. That's awesome, Wicked. Good to hear, man. Good to hear, buddy. Close you down. Let's see, what's our stream time at? Okay. Let me get our branch created. Behavior tree day. And push that up. What are you working on, Wicked? And, okay, good. In progress. That's what I like to see. That is what I like to see. Just a couple minutes here, guys, and we're going to get started. Give everyone a little bit of a chance to join in. Join in with the fun. Right. Okay. And sent. Turn that off. Good. Okay. You're working on your character system for a tile map-based RPG? Nice, Wicked. I like it. Is it a Final Fantasy type game, JK Software? A bit. It's a bit like that, yes. Hey, Mushroom. What's up? I want to implement serialization in C++. I'm going to give you, and by pondering, I mean freaking out. Don't freak out. Hold on, Mushroom. I'm going to send you down the right path here. First of all, don't go write your own serialization system in C++. There is no reason to do it. What you should use, and all of a sudden I just forgot protocol buffers. Took me a moment to remember. Don't go implement your own serialization system in C++. You can. It's not worth it. Go Google appropriate because it's developed by Google. It's called protocol buffers. They've ported it to a lot of languages, and it started in C++. So check out protocol buffers. It's very, very good. It's a really good serialization system, and you should use it. And there you go. I'm glad I can solve your entire problems in one night. All right, guys, let's get started. It is Behavior Tree Evening. But yeah, we are working on a bit of a Final Fantasy style, like, you know, a CRPG. Final Fantasy happens to be a very successful franchise in that genre. Ours won't be exactly like that, but yeah, of course. Wow. Unity up and running. Let's go into our scripts and create a whole new folder. And we're going to work on our behavior tree implementation. So first script that we're going to need is our behavior tree base object. This is going to be a mono behavior. Reload. Let's close all this. Just clean up our IDE here. This will be a mono behavior because this is going to drive our coroutines, and in Unity, coroutines can only be started from a mono behavior, but the rest of the behavior tree system probably won't be Unity behaviors. They might, I don't even know if we'll make them script behaviors. Go ahead. Let me know if that helps you out, Mushroom. All right, so we're going to keep this in here. We'll use this as we go. But behavior trees. I'm not going to go explain in too much detail what behavior trees are. You can definitely Google them. They're popular enough these days. But essentially, behavior tree is another way of doing a state machine-like system. So most game AI, not all, but most game AI is definitely finite state machine driven. Behavior trees are actually finite state machines. They're just done not in a procedural way, but an object-oriented hierarchical layout. But it's still finite state machines that we're switching between. It's easier for a developer to understand the tree structure than a finite state machine when you start to have 1,000 states. That's really what it comes down to. What's up, Brad? Happy New Year to you, buddy. F94 is done yet? Yeah, we finished last week. This is just a recording. Okay, so behavior trees. So what do we need from a behavior tree system? Well, we need a base class. And we're going to start with a new folder. So I just want to keep things organized. And I'm going to create a new class, and this is going to be our composites. So everything is going to spawn from our composites. And we're going to put everything into namespaces because we're fun like that. Now, what does it mean to be a composite? Well, for now, it's not going to mean a whole lot. All we care about is setting up some base class. So we want potentially a parent, because we might have a parent. What else should we have? Do I want to do a startup, like an initialization? Yeah, I think we'll have a startup. So we'll have a public. Do I want this? I guess void until I can think of a reason not to. Start. And we're going to pass objects around. I don't know what objects we're going to pass around yet. We might just pass around a game object. We might pass around game objects. Or something else. So we're going to have, and these need to be virtual. And we're also going to have, actually abstract is better. Yeah, abstract, make sure that you implement these. Don't just leave the defaults. Rather be abstract versus virtual here. I mean, it's still virtual. You just can't use the base. Now this is where we get IEnumerator coming in. And this is going to be our tick. And actually, I want to add another class. This is going to be an enum, which is an execution status. And we have enums. What enums should we have? I mean, there's success, failure, and I guess running and not. Let's put not running as a default. I was thinking, sorry, let me pull chat up. To have a playable build, that's right, Rab. Can you buy the game on Steam, Heck? Yeah, just Blue Spider. Can I talk slower? I will try. No guarantees. I am not known for my slow speaking, but I'll see what I can do. All right, so we have an execution status, and we want to return an IEnumerator of execution status. This is going to be our coroutine. Generic. What's going to be interesting is, does Unity support coroutines that return values? I don't know. We are going to find out. Okay, so here's a composite, and we're done. All right, we're not really done. Well, let's see if we can set up our behavior tree now. So from a behavior tree, it all spawns from our root node. And we'll have a tick. Well, this is an I. This is going to be a normal enumerator. Sorry, public. I think so. And this is going to be a run. This will basically run our behavior tree. And right now we're just going to yield break to compile. No, you cannot buy it on Steam. It's not done yet, Ek. No, we're definitely not done. Not available on Steam quite yet. Give it a little time. Soon, hopefully. Soon. Okay, so my behavior tree run. What does it mean to run our behavior tree? Well, ultimately, it's a while true. Every loop through the behavior tree is basically going to be the start of the root, and it's going to go down the tree. So every execution through the behavior tree is a full iteration. It doesn't mean that we get through the full iteration in one game frame. It just means when we get back to the top of this loop, it's going to be a game frame. I mean, it's going to be a full tree iteration. So that means what we want to do is say root, if root.start, what did I call it? That's not a component, composite. Composite, right? So we have a start method. Why doesn't it like this? And we want to pass in our game object. And then we want to tick var status is equal to root.tick, our game object. And depending on what the status is, we might break out of the behavior tree. You cannot, no, not right now, Ek, not right now. Oh, we need our components, yep. So we can get back the status. Oh, sorry, this should be a yield, sorry, this should just be here. And that will be a yield return. So status. I'm thinking. Do we actually care about... I think all I want to do is yield return tick. We don't really care about the status of the result of the root object, because we're just going to keep on running no matter what. And there's no breakout here. We're going to have a private bool should run, which by default is true. And then actually while should run. And then this might break us out. So we can have a public void stop method, which just says should run is false. Public void start, and this is where it's going to start. Should run is true, and then start coroutine of run. Oh, we can't use start tree and stop tree. Okay. So this will kick off the behavior tree to execute, and we have a way to stop it now, just in case we need it. And while it's started, we'll be in a coroutine that's just looping through our composite. Now we got to start building up a library, and ultimately, guys, this is a behavior tree system. We're kind of done. We're not really done, but we have the basic framework in place for a behavior tree system that we can use for AI. We have to start building a library of behaviors, base behaviors that we can use to extend. We will start getting some very basic behaviors going. So first thing I'm going to add is an action, which is based off of a composite. And implement. There's our start, and there's our tick. And when we create, we need a constructor. Oh, sorry, hold on, message come in. What is this? Okay. All right. So we want an action basically just means execute something. So if this pops up in the tree, all it does is execute our action. And run status, we actually don't really care about start. All we really care about is our runner. And for our runner, I'm thinking if I just want to use a delegate, or should we use, well, delegate, we can still use lambdas, which would be fine. Yeah, let's use a delegate, which will return a run status, or an execution status. And this is an action delegate. Which should take in our game object. All right, so there's an action delegate, and that's what we want to pass in here, which is our runner. And do we need one by default? Yeah, we should always have an action. And we want to have a private action delegate of our runner, just so we can store it. So when we start, there's actually nothing, we don't need to override, oh, we have to implement, no. From composite, we do have to implement start, because I made it, which is fine. We just won't do anything. And then in tick is where the action happens first, where the fun happens. Oh, this should return back in, should this be a coroutine as well? I'm thinking, I think we should. So this should be an I enumerator of an action status. And that way, if runner is not null, we can basically yield return the runner of our object. Very simple. Otherwise, if they didn't set one, we should probably just yield return a action status of failure. All right, what doesn't it like here? Oh, we don't need an I enumerator. Duh. Okay, so that's it for an action. I know this doesn't look like a lot, guys. I know it doesn't seem like a lot, but we are getting our library kind of built up. All right, new class. What do we want to do next? I think I'm going to do a decorator next. Or do I need a group composites? Don't really do decorators off base composites. Yeah, I think I'm going to do a group composite now. A group composite is really just a collection of composites, and that's going to be a base class that we use for like selectors and sequences and parallel and things like that. We're just building up a library. Okay. So in a group composite, we need a constructor. And we're going to use a params of composites for children. And this, do I want to keep this private? No, we'll make this publicly exposed. Public list of composites of children as getter setter is equal to, probably need to be a little careful. I was going to do something there, but and for each, no, this, actually we can do it this way. Just do children to list and we'll be okay. So we also want to know what's currently selected. Thinking ahead here, public composites selection as getter sets. And that should be it. So do we need anything in start? No, we actually don't need anything in start. But we might want to call, we should start getting in the habit of calling base.start. Can we call base start here? Oh, because we're in abstract now. We'll start calling that elsewhere. But we don't need anything in start for this. In the tick, we don't need anything either. But we need to implement a tick otherwise, because we made it abstract. Can I get away with? I don't think we can get away. No, of course not. I think I can just keep it abstract, though. Let me see. And we can do the same thing here. Or can we? But it is contained in non... Oh, yeah, that's right. Make this abstract as well. Hides and... Oh, all right. So I guess we can't make these abstract. I was hoping I'd be able to forward through the abstract. That's fine. So we'll just return a... execution status failure until we override it. We don't do anything with start. Let's add a couple more. Public void add child, which will just say children dot add of child, and this actually should just be a private set. Or a, yeah, private set. Public void remove child. Actually, should we ever remove a child? No, I don't think we ever need, we never want to remove a child. Because that would mess up our enumerator. It would be very weird. Okay, so that's group composite. Now I can actually build decorator. Because our decorator is based off of our group composite. And a decorator doesn't have, we're going to have our own constructor here in a moment. A decorator basically is has a can run kind of delegates, which I'm thinking if I want to implement generically or not. Which I guess so. And we actually don't necessarily need a can run, but I want to put it in there. And then we'll have a decorator child, which is just node 0. Okay, sorry. So we'll have a public delegate of bool can run decorator delegate. I can spell. If I will it, it'll happen. We should pass in a game object. And then we're going to actually have two constructors here. So this is a can run decorator runner, and it's going to pass in a composite child. And this is going to call our base of child. So that will get set. And then I want to have this as can runner. And this is going to be optional. I'll show you in a minute. And that's that. Let's add a public composite of decorator child. Which is just a get. And this can just return children of 0. Okay, so do we need a start? We actually don't need a start, so we don't have to worry about implementing that. It's already in the base class. We do need an execute, of course, so public override tick. Just check something here. Okay, good. Keep overriding it. And if the can runner is not equal to null, if we can't, we'll execute the can runner, and if it returns false, we just want to do a yield return runs execute status of failure, and then yield break, right? We're done. It failed, we can't run, we're good to go. Otherwise, we don't care. We can just get out of here, right? And then, what do we want to do? Okay, so we want to execute our decorator, which is like its own mini tree. By the way, a decorator basically is another kind of root node that will have one child, and that can branch out. So we want to say decorator child dot, which means we want to call start on it of our object to initialize. And then while, this is where we start using coroutines. So since we're in a new node, we want to stay in this coroutine while the child is still running. So essentially, so while decorator child dot tick of object is equal to, what does tick return? Is this, this should return back, it wants to be an enumerator, but it should result to an execution status, I believe. Unless I'm thinking about this wrong. Maybe tick should, because we want this, or do we want this? So I'm thinking here for a second. We'll see if I can yield return there. No, so decorator child of tick of object Rx. I'm trying to remember how to do a coroutine that returns values. I might have to look this up real quick, guys. What's up, Void? Start in the base class just returns failure. We don't. Start doesn't return anything. How you doing, Void? All right, I'm gonna look this up because for some reason I'm a dummy and drawing blanks. Routine return value. For some reason I can't remember how to return a value in an IEnumerable. And this did not help me at all. Yield return value. Has it been so long? Has it been so long? I mean, we could do a for each on it, but I'm thinking, what is this going to do? I'm trying to think how this will work in the Unity world, right? Because really, this should... We kind of need to bubble this all the way up each tick. And if I don't bubble it up, it's we're going to get stuck running the whole decorator at once. And I don't want to do that. You've been messing around with DirectX 11? That's nice. It's much cleaner. Oh, it's so much cleaner than OpenGL. So much better. So normally what you would do here, guys, is we would get the tick here, and then X could get current, or we can move next, which will let us know if we can move next, right? Then we can get current and all that fun stuff. I wonder if I should get the context, which will not execute it. It'll get executed when I call move next. This will run one yield frame for us. So I think we'll do this while context move next and context current equals running. So this will do one iteration for us. We want, okay, what we'll do is we'll yield return running, right? So this is how we'll do one iteration. We'll basically tick one iteration, and this will keep ticking until we're running. And then once we're done, oh, you know what we should also store? Should we store like a last status? I'm thinking if we should. But then that means I'm going to go implement composites. Yeah. That's what I'm thinking about doing. Oh, sorry. Just going through my head. Going through my head here. Because there might be another way we can implement this. So tick and execute. I think that's what I want to switch I want to switch our system up a bit because this is starting to expose a problem for me. And this is not very clean and I don't like it. So what we're going to add is a new method. This is not going to be abstract. This is going to become, should we make it virtual? It's not even going to be virtual. We're just going to have an execution status of tick. And then we're going to create, this will become public abstract I enumerator of execution status. We're going to create an execute method. And then now let's implement this. Okay. So tick. So now we don't have to worry about ticking in each of our methods. We just have to worry about execution. I'm streaming again. I stopped and I restarted, buddy. How's it going, Ufius? Oh, 1 second here, guys. Okay. And then this will also let us do a last status now. Public of execution status, last status. Add a getter setter for last status. So in tick, as we tick, and yeah, this will even know if we've started ticking, right? So if last status has value, and last status is not equal to running, we could just return the value. So if we're already done running, there's nothing left to tick. We're done, right? Otherwise, we also need to store some more data here. A private composites. This is our current item we're executing. If, try that again. If current is null, means we have not started executing anything on this item yet. Well, actually, hold on. Should current ever be null? Because current, actually, that's where, no, current should never be null. And in fact, that's what start's going to do for us. I'm sorry, yeah, so that's what we're going to do in start, now that I think about it. So we're going to get rid of that, and we're going to implement start. This is actually going to become virtual, in case we want to override it. Execute's the only thing that's abstract and must be implemented now. I'm liking this a lot better. So in start, we'll say current, first of all, last status is a reset. Make sure we null that out. Current now is going to be execute of our object, our context. Get, we actually don't need to get enumerator there, do we? This is going to be returning an I enumerator for us already. And that's what we actually want. This is not a composite, this is an I enumerator of composite. That's our current. Of execution status. Oh, we got to fix this. This should be returning a... Oh, no. This should be an execution status, right? Yeah. So this will get us our current. Okay. Whew. So now, if we don't have a last status, we have a last status set, just return it if it's not running anymore. That makes sense. And then we'll say if current dot move next. If we can move next, last status can now be equal to current dot current. Otherwise, should we ever get here? We should never really get into an else here. We should always exit out. And then at the end here, if last status not equal to running, we're kind of stopped, right? We should basically stop ourselves. Do I need to implement a stop? Do I need to implement a stop? I don't think I care about stop. So I don't think I even need to worry about that in this. We just want to return last status that value. All right, so here's our ticker. Boop, boop, boop. This will tick once for us. This is starting to look better, I think. I'm going to think about this through when we get back to our behavior tree. Ufius, you were celebrating New Year's Eve with some friends. Nice, Ufius. How'd it turn out? Because of it? That's right, internal. That's how we do it around here. That's how we do it around here. So this is going to iterate through our composite for us. And this will start the execution. And then this will iterate through until we're done. How will we ever get back to start? Let's think about this. Somebody has to call start to set this up again, which is okay. All right, so if that's the case, let's go back to our action, because this does not work at all anymore. Instead, we don't even need to override start. We need to implement execute. And execute is just going to return runner of object. So what is this return, and what doesn't it like here? Because it's looking for an I numerator. Do I need to cast this? Oh, no. The execute, does execute return an I numerator? It does. But that's where we can, oh, that's right. We can just yield return the runner. Boop. Okay. And that's an execute now. Execute's finished. We had a group composite that we have to fix now, right? Do we need to start in group composite now? I don't think we still need a start. And we just, well, hold on, let's see, think about start. No, we don't need a start, so we can get rid of start. Do we need execute? We actually don't even need to put in execute. We don't need tick for sure. Because a group composite doesn't do anything, we do need to implement execute because it's, yeah, which is fine. So we'll just do a yield return of failure. But this should never really get called. Like our decorator is going to implement execute. This is a base class that should never really be used. Let's see here. One second, guys. Okay. What's going on in chats? Please stream until midnight so I can say I have been watching you all here. Okay, Void. Well, I'll see what I can do, buddy. It's 5 a.m. already, Euphius? Well, not for everybody. All right, so that's our group composite. Let's go back to our decorator. And this is going to change because this needs to be our execute now. And okay, and we'll have to do some fixing up here. But in our decorator, let me think here. Do we need a start? We don't care about start, but we do care about execute, and this is where we want to execute. So this will do a yield on us. This will do a decorator child. So now I actually don't need to worry about, I don't need to do this. We don't need to do it like this. We can simplify our world because of how we've changed tick around. Now we can just do a while decorator child, since we started, and decorator child, that means we'll get its own internal execution. We can do while decorator tick, we can call tick directly now, is equal to running. We can yield return running. And then otherwise, We can stop. And what do we want to return? Yeah, and we want to break X. So normally after this, I could just say, okay, after that, we don't know what the we could just yield return decorator child last status dot value. Right, we could do this. The problem with that is if this is a failure, I don't want to keep executing this because this does not necessarily break us out if we're in another loop. So if this is like a decorator, so what I want to do, if we're like in if this decorator happens to be in some type of loop type or a selector type, I want to actually check, say if decorator child last status is equal to failure, we want to return direct failure and then do a yield break and just be out of here. Otherwise, we can just do a yield return of success. What's up? What's up, streamer? It is a little late, but why not? Why not, right, buddy? That's what you have to ask yourself. All right, so decorator is fixed now. Everything actually should be fixed up. Let me see if we compile. Everything might not be fixed up. Everything is fixed up. But if I go back to my behavior tree, is this still what we want to do? Yeah, so this is actually what we want to do. And if you look, tick returns our execution status, and we can just yield return that. So this will run through one tick. This is perfect. This should definitely run through Unity's coroutine system. And we'll be testing it, don't you worry. So I have an action. We have a composite. We have a decorator. We have a group composite. I wonder if I should add a simple, so that we can actually get in and test this now. I think I want to add so decorator is also a base class, right? Like I said, let's actually add a decorator, which is, we're going to call it weight. Not weight, yeah, weight. And this is a decorator. And we will implement our own constructor. Public, weight, timeout not int, let's do float, timeout, seconds, and seconds, and then do we need a composite? We do need a composite child, right? We're going to have a couple. We're actually going to have a wait action as well. But this will make sense. So we have a timeout seconds, and we kind of just need to have thinking, do we just need to have, do I need a start? I don't even think I need a start. I'm just going to have execute. Yeah, we're just going to put a simple execute. So public override executes. We're not going to call the base. What this does as a decorator is it's going to wait this amount of time, and then it will execute the child. And that's all it's really going to do. It's very simple. So to do that, though, since we're an I enumerator, I'm hoping I can just return new wait for seconds. I'm hoping. Oh. We need wait time. Timeout seconds. One second here, guys. Sorry. Send a message. Okay. Wait time. I don't know if this is actually going to work. Because this is a yield instruction, which, so we're gonna we have to build our own waiter. It's not a big deal, but basically we have to build our own waiter, right? Current, I just want to say, can I get current time? What's fic time? The time has started. This is time in seconds since the start of the game. So we can use fixed time. The time the last amount of behavior has started, the time in seconds since the start of the game, right? Okay. So we'll have float wait time, float start time. And we're gonna actually implement our own start, our own start now. Public override start, we'll call base. And then we want to say start time is equal to time.fixed time. And then while time fixed time is less than our wait time, our start time plus wait time, start time plus wait time, yield return running. So we just implemented our own pause, right? This base is going to implement our own pause into Unity for us. Once we're past that, we can. Oh, actually, no. I wonder if I should. No. That'll be fine. And then we can basically do decorator child like we did before. Decorator child dot start of our game object. And then while dot tick of our game object is equal to running yield return and then in here we can just if actually when I think about this, I don't really care about any of that. We're just going to do a yield return. Oh no, this is going to because we have to keep ticking through this. This is only going to tick it once and then we're going to return out. So unfortunately, I was hoping to be a little tricky there. We still have to do that, but then we can just do a yield return of decorator child last status of value. All right, Screamer. Hey, what's up, Trump? Let the flame war begin. Oh, God, Trump. But either late Happy New Year's or early Happy New Year's. Both of those work, right, Trump? Both of those work. Give me a second here. Okay. Yeah, I talk all the time while I'm coding Nufius. It's called rubber ducking. Just Google rubber ducking. A lot of developers will talk. Well, they might not talk to themselves. They might talk to like an object. You might talk to an object or something. But yeah, I do it all the time. Just helps my thinking process. And I've been streaming software development for so long now. I think 2 years now. That it's I can't get away from it. So this is a wait behavior that we just created, and we have an action behavior, right? It doesn't work for you, Void? Well, you broke something, man. You broke something. I want to test everything we've done so far, by the way, guys, because I want to make sure I'm on the right track. So how do we test this? That's an excellent question. We're going to use our character create here. And I am going to do it this way. Where's our prefab? I'm going to drag our hero onto the scene. And then on our hero, I want to go to scripts, behavior tree. We have a behavior tree that we can add here. And then we're gonna mock up some code. We're gonna make some test edits in our battle components, and we'll do this on starts. So var behavior tree is equal to get components behavior tree. And then behavior tree, we actually have to construct our tree right now because we don't have a behavior tree. We'll get to that functionality later. Because I could just say start tree here. I mean, we're going to, but it won't execute anything because this behavior tree is empty. What we want to do, did I not add a way? I guess I should add a way to set the root. But before we do that, let's set up a behavior tree so that we can pass it in. I had to keep you occupied, Screamer. Oh my god. Screamer, buddy, I'm here to help. I am here to freaking help. Alright, so let's build our behavior tree. And what is our behavior tree going to be? It's going to be a wait into an action. So where can I just want to build we'll build it over here. We'll add it here. So I'm going to add a new composite, new class, what do we want this action to do on our game object? We'll call it a fade. We'll call it a destroy action, which is based off an action. Yep, which takes a, this is not going to take a action delegate. We're going to create our own. We do need a constructor though, but that's fine. Private, execute, destroy, game object, public destroy action. In our base, we have to pass in a delegate. I'm just going to pass this in. Will it work? Will it take that? It wants a method group. I could pass it a lambda. Can I pass it a lambda in a constructor? I don't know if I can do this, actually. Oh, private. Oh, maybe because I messed that up. Let me try this again. Hold on. Okay, it likes that. Let me look at action again. We just execute the runner, which needs, our execute needs to return an execute status, right? Let's fix that. Was it, yeah, execute stats. We just need to implement this now. I think we'll be good. So if by default, we just say success. Will it take this? Object reference is required for, I can't, I can make this static, private static, just for testing purposes. I should be able to make this static, and hopefully it'll take it. Okay, it'll take it. And it could be static, by the way, because this is a reentrant method for us. Duck detected a typo in destroy. Did I mess up? Oh my god, I cannot spell destroy, guys. I can't do it. I can't do it. One moment here. Oh my god. Wow. Am I terrible at spelling destroy? Or what? It's 4K. Streamer, that's your New Year's resolution? I like that New Year's resolution. I can't type over here either. Okay. We actually don't want to just return destroy, by the way. What we want to call is game object dot destroy of object, and then return success. That's all we do. So now we have a destroy action. We have a wait decorator that we can pass in a destroy action in a wait time, and that's our test. So if we go back to battle component here, what I want to create, we need a root node, which is just going to be our wait action. So RPG, what is our, I want to get our namespace. Assets, blah, 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 that's right. Wait, node. So what do we pass in here, right? Is a timeout in seconds. So let's say 5 seconds. And then we pass in a new destroy action, by the way. I can't get past it. And let's go fix it. Even though it's a test action, I have to go fix it. Rename. Yes. Okay, fixed there. Did it fix? Okay, fixed it everywhere. Okay, send that. All right. One day. So we have our wait node, and this is really all we need. But what we want to, we have to hook this up into our behavior tree, which I forgot to expose, is to set the root node. I'm going to add that now. Set root of composites, root. And now if we have our wait node, bt.setRoot of wait node, and then we could start the behavior tree. So if everything goes as planned, when this starts executing, we'll wait 5 seconds. We'll wait 5 seconds, and then we'll execute our destroy action. And our destroy action should destroy our object. Only one way to find out if that's really going to work. What's rebuilding here? Where'd our guy go? Where'd our little dude go? Why? Oh, we don't show ourselves anymore, do we? I'm going to turn ourselves on. All right, let's just run this and see if we, have any bugs like we do right here. Like we're just spawning through. So in battle component update 160. What's going on in 160? We don't have, well, that makes some sense. Object reference not set to an instance of an object on 142 as well. Oh, we don't have a battle mat. These are easy fixes. What I'm going to do is reload this scene. And this might be enough, because I think now we'll find the battle mat. Let's see if this works. Okay, so we have our guy here. I'm hoping, and we should put some, there are 2 audio listeners, please ensure there's, oh, how do I have 2 audio listeners? I don't know how to fix you. I don't know, you gotta go away, man. You gots to go away. Gots to go away. And why did he get popped in here? But more importantly, what I want to do is go into our wait action and put some breakpoints here, here, and here, and see if we actually hit 5 seconds. Connect up. Play it again. Okay, so good. Well, 1 second, guys. Okay, so we have a start time. Fixed time says it's 0. This is not looking good for me. Oh, fixed time is now moving up, but this is supposed to be seconds, right? You go away. Oh, why is start time? Ooh, this is bad. Start time should not be restarting. So basically, we are never getting through here. Let's look at our call stack. I got a bug. Yes. So while... Oh. We're going to yield this. I need to fix this. Terminate all. Easy fix, guys. While root.tick of game object equals running yield return, just yield return null. So we have to have a loop in a loop, right? So this runs, this will run one iteration of the behavior tree, tick by tick through the game until the root returns finished or failure, and then we'll restart it all the way again from the start. All right, let's try that again. Debug, attach. Hey, Rad, welcome back, buddy. Welcome back, sir. I'm just trying to stop our... Okay, let's see if this works now. Because I might have to stop... well, not stop our debugger, but restart the game. This is what I'm trying to do. So we have start. And here, okay, so start time is 0. Start time plus wait time of 5. I just want to make sure we never get back in there. Oh, but we never actually get back into here either. Oh, of course we never get back into here because we hit the top of the while loop, right? So if we look at fixed time, boom, we're at 5 seconds. And now we're going to delete. So everything actually is working as it should. That was I think that was our bug. And we got deleted, right? So let's rerun that again. So as soon as we start, it should be 1, 2, 3, 4, 5, and we're deleted. Our behavior tree is working. So we were able to wait 5 seconds. We didn't block the game. More importantly, guys, we don't block the AI, especially have 2 parallel nodes running, which we're going to implement. We have our own wait happening. I'm going to go build I'm going to stop debugging. I want to build a wait action. As well. Which is going to be just an action. And it's going to be like our destroy action. But it's going to be an execute wait. And we're going to just copy a bunch of code over here. Just 2 ways for us to implement waits, basically. So now public wait action float wait time, and then base execute our wait. Wait time is equal to wait time. Get you in there, and then we need to override our start so that we hit a start time is equal to game time of time dot fixed time, and just copy this code. Boop, 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 boop. Oh, crap. How did this work? Why did this work? Oops. Oh, that's because that's our wait action. This becomes a bit of an issue, guys. Bit of an issue. that I need to think about, because now that this is static, see, now I got to get rid of the static here. We got to figure out how to get rid of our static. No, I know that's why, but now I want to get rid of static because then this causes a problem. I need a way. Let's actually go to action, and maybe we'll have another way to set the delegate. So if we have a default constructor that doesn't do anything, and then a public void set runner, which takes our runner. And for code reuse, let's fix you. And then if runner is not null, else yield return failure, because we never set a runner. All right, so if we go this way, we don't have to set a base. Can I then call set runner and pass execute wait this way? Well, and this needs to be an I enumerator. I think. No. Man, I can't even remember what I was doing here. So this just needs to be you, and that just needs to be you, right? And I think we can get by this way. Okay. Does it run Crisis? Yes, it does. Internal static void. Okay, but this should do what we want to do. And we can rewrite now what we just did in a different manner and use the wait action. So let's do that. So instead of using a wait node that has a destroy action, what we can just do here is I want to chain two. So we actually have to implement another composite real quick. We need to implement a sequence. Implementing sequence, which is a group composite. Okay, so a sequence is nothing too crazy. We do need a constructor though, public sequence, which is going to be just like in our group sequence, params, composites of children, base children. That's all we need. Okay, excuse me. Then we need and all we have to do is implement the execute, override execute. And this is just a for each var child in children. So go through each child. We want to say child.start of our object. Make sure it starts. And then while the child tick of object, just like we did in our decorator, is equal to running, yield return running. Oh, we also have a selection we need to make sure we set. Is set to child. After we're done, a selector node in behavior tree, or sorry, a sequence node in behavior trees runs through all the children as long as they're successful. As soon as it finds the first child that fails, we break out. And you can actually use that for flow control, because you can go 1, 2, and then don't execute the third, and everything below it won't happen. So you can use AI like that. So basically, you're going to have a sequence that says find player, attack player. If find player returns false, we'll never attack the player. And that's a very basic behavior tree, right? And that's how simple the states can be. Find player, attack player. If this ever returns false, we'll never attack player. And you can keep them very discrete pieces like that. So then we got to check if child last status is equal to failure, yield return failure, and then yield break, because we don't want to continue. Otherwise, we keep executing, and then at the end, we just want to do a yield return execution status of success. Because if we never got into here, that means everything was good. And there we go. We just wrote ourselves a sequence type. Because now what we can do is we can create a sequence. Instead, we can say sequence root equal to a new sequence. And this will take in parameters for us. And we want to pass in 2 nodes in order. We want to say new wait action. And it's going to have our same 5-second wait. And then we want to pass in a new basic action, and I'm going to create a delegate here of object, a lambda here. So we're getting a little tricky, but that's okay. I think this will let me use it. Will it? Will it? Will it? Yeah, we just got to return success and okay. Next, we want to set root. This is going to be the exact same behavior tree, just written in a different way. Because in here, I'm going to call destroy of our object. So we are now waiting for 5 seconds, and wait action always returns true. So this will always then execute this, and this always returns true. It doesn't matter what this returns because it's the last node, but that's fine. So implemented the same way, same functionality, just different ways. Let's make sure it works. You fixed it, Rad. Also updated, but apparently C code no longer compiles. Can't locate. Oh no, Rad, that sucks. I just want to make sure he dies in 5 seconds. Otherwise, if he doesn't, we got ourselves a bug. It looks like we got ourselves a bug, by the way. What is with these audio listener problems? It's probably because I added this both scenes here, right? It's because we have 2 scenes running, which we normally shouldn't have like that. All right, we got a bug. Well, darn it. We start our child. We execute our child. So let's see if we get through each child. I'm sure it's something simple. That's why we start with these base primitives, test them out, make sure they're working before we move on to more complex primitives on top of it. So this is our wait action. I'm going to put a breakpoint here because we set a start time. And honestly, anytime this gets started now. So now we're waiting 5 seconds. 3, 4, 5. Are we never ticking this? We never tick. Well, did we tick this at all? So we might have to look at the action here. So we're in execute. So now, all right, let's go look at sequence. So we should be in here, right? Okay, so, set our last status. That's in composite. That's there. I think we never run back into our while loop. Yeah, see what's happening here? We're in this, we never call tick again. Is this a mono, is this a mono thing? is this a mono thing? Because this should keep getting called. Child tick should be getting executed. Go to implementation. Well, maybe it is. Let's put a breakpoint and see what's going on. We are in last status is running. So this is inside our sequence. Now we're inside of our, still inside of our sequence. Last status is set to running. Move next. This is in our action. Let's see what this is getting us. So move next does not move us next anywhere. So that's why we're still running. Get rid of all of you. Why is action not doing anything? So we yield return our runner. And we call this this should be getting recalled every execute. Because then it should come in here. It should then execute this. Oh, should I not be doing a while time? No, this should be... Oh, this is... we're stuck in a while loop here. What did I do with our other wait? Was this a while as well? Should this just be an if? Oh, you know what? Execute. Oh, right. That's why this is running. My wait action is done differently. This is what happens when you copy and paste code, guys. This is not a coroutine. This is just a method. So we just want an if, right? If our time, return running, otherwise return execute. So let's keep this here. This should now get triggered multiple times. Debug, let's attach. We were basically, we put ourselves into an infinite loop almost. Oops, not wrong, attach. Debug, attach Unity debugger. Is this Unity? It's Unity, Root Killer. Let's stop and restart that. Have you ever faced a compiler bug? Yes, Euphius, I've faced several compiler bugs. So we get our start time. We're going to hit our runner, which is an if, and crap. We don't keep executing this, do we? Well, we should keep executing this because we should be in a while loop. We yield return our runner object. I'm thinking this through. Because this returns running. Why are we not executing back in here? Because in our sequence, right, we're definitely executing through here each time. Our composite, this is our behavior tree composite. This is running through the execution of, and this is in a while loop. I wonder if I just need to move that to a while loop. I think that's what we need to do for actions. So action, if runner, while runner is equal to running, yield return running, and then after we're done, yield, I need to store this in a variable, var, not var, status. yield return we have to keep executing this. What doesn't it like? Oh, that. Open this. Always good to fix your compilers. Okay, so this will now keep executing the action while it returns a running status. And then we'll return its status once it's not running anymore. Okay, so if we go back to our wait action, now I think we'll get it. I think we're going to get it now, guys. Root Killer, that's another project that we're working on. This is our holiday holiday side project, I guess you can say. Okay, so time, return, there we go. There we go. Now we'll wait 5 seconds. And we should hit into here. There it is, guys. So there's success. Yield return, set last. This is our sequence. We're going to go to the next child. Okay, good. And of course, we get deleted. All right, let's make sure let's just run it one way through. That's right, Cropper. 1, 2, 3, 4. There we go. 5 seconds. So same way, or same end result, guys, right? We wait 5 seconds and then we delete our object and we implement it 2 different ways. That's one of the good things about behavior trees. There are so many ways to slice up how you write your tree. I love you too, Cropper. Happy New Year, guys, by the way. Happy New Year. Okay, what else do we need to do right now? Debug, detach. Okay, so we have action, we got a wait action, we have a wait decorator, which is kind of like a wait action, but can be used differently. We got our sequence now. Maybe we should go implement the opposite of a sequence, which is a selector or like a priority selector. All right, let's do a priority selector. Do I need to implement a selector first? Probably, because there's different types of selectors. There can be random selectors, priority selectors, all types of stuff. You can do weighted selectors, probability selectors. You can do all that type of fanciness. So let's just have a base selector class, which of course is a group composite. And takes in our params. Of children. And that's kind of all we need in a selector. Thank you so much. Oh, actually, you know what we want to make sure we do is, since this is an abstract class, by the way, we don't do anything with a selector. It's just another base class, public abstract override our execute. This just makes sure that we're not implementing execute, but anyone who implements selector must go implement execute. Otherwise, things won't work. Okay, so now we can do a priority selector. And a priority selector is kind of the reverse of a sequence. So a sequence goes in order of children and will break out as soon as something is false, right? Class priority selector. Priority selector will go through the list of items, and in the first one that returns true is done, right? So we just want to find the first selected item. And we need to implement a constructor, of course, of params, composites. Children. Base children, yay. We can even have... Do I care? No, I don't care about for that. All right, so for each var child in children, capital C here, we want to say child.start, our object, while child.tick of object is equal to running yield return running. And then we just do a simple check. If child.last status is successful, yield return success, and then yield break. It's almost the exact opposite of a selector. Selector goes true, 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 false, and we're done. Whereas this, the first one that passes is we're out. And use priority selectors basically for prioritization, right? You can have, and you want to have them execute in priority order. Maybe you have an AI that says find player, find first player, or find player, and then maybe find player's sidekick. Maybe you have a sidekick in the game, right? And that's the priority selector, and that's the order. So if the AI cannot find the player, it will then attempt to find the player's sidekick second. But if it can find the player, it will prioritize that. That's what a priority selector is up to. How up to date is Unity C#? What version is it up to now? I don't know. It's whatever mono version it was at. I think it's up to like .NET 3 or 3.5 maybe. Something along those lines. Okay, so, and that's a kind of a priority selector. Do I need anything else? I'm thinking, oh, we want to set selection in here. I have to unset our selection too, guys. I have a little bug that will creep up on us later. And then once we get out of here, we're not selected anymore. So this is where my bug's kind of going to be. Oh, and then of course, if we get through everything, it's the exact opposite as well, right? Yield return failure. So if we couldn't find any child that successfully executes, this whole priority selector fails. And that's good, because you can have priority selectors of priority selectors of priority selectors of sequences, right? It's a tree. Think of it like a binary tree, or not a binary tree, but think of it like a tree structure. And that's a behavior tree. If we go back to our sequence, not a selector, sorry. We need to set selection to null. This just allows us that while we're inside, when we're executing, when we're ticking a child, we know what child we're ticking. If we have code later on that needs to communicate back to behavior nodes, this gives us access to it. So to tell you the truth, guys, the composites that we've just executed here, we can implement the most complex AI. This is the basic building blocks of a behavior tree system. This can take you anywhere. Obviously, we can add more, and we're going to add more on top of this to make behavior tree writing even easier, but this is all we really need. Like, we can add a decorator continue, which basically is a composite of an action, and if that action is successful, then continue, otherwise, fail. We can do repeaters, which is like a loop construct. We'll probably do maybe like a switch construct, so we can do an if, else, if, right? If, else, if type of situation. Yeah, so there's a lot of stuff we can do here, which is good. 5.6 is supposed to come with .NET 6 support static. Is that going to be .NET Core? Essentially, are they going to try and move to use .NET Core? That will be pretty good. That's going to be a huge change, though, static. I don't even know how that's going to affect people. I wonder if it basically just new projects will use it and not old projects. That's what I'm thinking. Let's make sure we delete again. Boop, boop, boop. Okay, good. Still not broken. Let's actually delete you now. Let's unbreak what we broke in our battle components. Really just all this test code. Let's unload here. Let's make sure the game still works, right? Important to make sure. Okay. Walk. And, oh, he's dead. Next game. Okay, walk. Oh, he's dead. Oh my god. So beautiful, guys. So beautiful. Okay, we didn't really break anything. All good. Do a little commit here. And there we go. There we go. So there's the building blocks. The building blocks to a behavior tree system. It works within Unity, works in Unity coroutine, so the behavior trees execute through. It doesn't block the game when it's executing. It's great stuff. Is the worst part of vacation. Sorry, Trump, that is the worst part, but it has to happen, right? But guys, it was just going to be a short stream tonight. That's why it's day 3.5. We got almost 2 hours in. I'm going to be calling it a night. Happy New Year's to everybody. I will be back tomorrow morning, though, everyone, and we'll be finishing up the AI system. So tune back in tomorrow if you're around. Otherwise, sleep it off. Have fun. It's New Year's tomorrow. Enjoy. Enjoy the rest of the night. Good night, everybody. See you next time.